Good morning, students. In our last class, we have discussed the physical properties of both alcohol and phenol. Today, we are going to start the chemical properties of alcohol and phenol. Now, students, the chemical properties of these compounds is because of the polar nature of the O-H bond, right? In case of alcohol, it is because of the polar nature of the two bonds. One is O dash H and second is C dash H, C dash O H. Whereas in phenol, students, we get the properties only because of the polar nature of O dash H bond. So just have a look here. We are going to discuss it. So let's the chemical reactions of alcohol because of polar nature of first is O dash H bond, that is, we will write it as O dash H bond, and second, student, it is this one, that is the polar nature of C dash OH bond, right? So when it is acting as polarity of O dash H bond is concerned, right, you know this will get the del positive, here it will be del negative, and it has got the two lone pair 2 on it. So student, here it is acting as a nucleus loving center, which is acting as a nucleophile. Whereas in this case, student, here it will be C dash OH. Here it is acting as a electrophilic or electrophile center, right? So for it, yes. So now we will discuss these reactions under the two main headings, student. One will be the reactions involving the breakage or cleavage of O dash H bond, and second will be the cleavage of C dash OH bond. Right. So first the properties is related to this, and this bond chemical properties will be involved in phenols too, but this will not be there. This when we will start the reactions we will come to know. So first we have reactions involving cleavage of O dash H bond, right? So here the first property, student, is the acidic nature. Now here let me tell you that both alcohol and phenol, students, they have got the acidic nature, and the acidic nature is because of the polar nature of OH bond. As a result, the OH bond breaks up and a proton is being liberated, right? So here the acidic nature is because of the polar nature of O dash H bond. Polar nature of OH bond. Right. Now let's take example first, on which it will react with active metal sodium and it will liberate out hydrogen gas. This is a reaction which will show that the alcohol show the acidic nature. It reacts with active metal sodium hydroxide is formed. Right. Similarly, students, if we have a tertiary alcohol, this is this OH, now I'm writing it in this way, ROH, bond showing here it is aluminium, so it will form CH3, 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 right? This is cold thrice aluminium, right? This is there. So this will be formed. This is the tertiary alcohol when it reacts with aluminium, right? It forms tertiary aluminium alkoxide, right? So this shows that the alcohol reacts with the metal as like with the sodium or with the aluminium, right? And it forms the respective alkoxide. So here we have two, liquid two. So this is the tertiary alkoxide. Right? Now, this reaction shows that the alcohol is showing the acidic nature. Similarly, alcohol react with NaOH to form sodium alkoxide RONA, right? And water is liberated. That means this is a base. It is reacting. Its alcohol is showing the acidic nature, and it is forming a salt, and water is being liberated. This reaction also show the acidic nature of the alcohol, right? Similarly, student, phenol is also there. Phenol, it will also react with active metal sodium and will form sodium phenoxide, and hydrogen gas will be liberated. In the same way, phenol will also react with the NaOH. Phenol, it reacts with NaOH and form sodium phenoxide, and water is formed. This is sodium phenoxide. Right? Now these reactions show that they are acting as this is base, this is the acid. So a base is reacting with an acid to form a salt, and water is formed. Right? Now students, this is clear that alcohol show, we can say that hence alcohol and phenol both show acidic nature. Now we will discuss its acidic nature, student. So here this is ROH, right? And if a base, if the base is this is the base, student, hydroxyl, right? If this is come in contact with it, that time this bond, oxygen is more electric, this bond is polar in nature, right? So here it is partial positive, this is partial negative, this bond will break down and it will form RO negative plus H3O, sorry, it will form H2O here. Right? So here ROH is acting as a proton donor. So this is going to be a conjugate acid, or we can say a Bronsted acid, and this is its conjugate base, student, is this one. Right? So this is the conjugate acid and its conjugate base is this. This is the acid-base pair, and we have discussed it in class 11th also, that the Bronsted acid-base concept, a proton donor is the acid and a proton acceptor will act as a base. And if such a pair which just by exchange of a proton can be converted from an acid and base, will be known as a conjugate acid-base pair. So here the pair is alcohol and the alkoxide ion. This is called as alkoxide ion. It is a one conjugate acid-base pair, and similarly OH negative and water is another conjugate acid-base pair. But if we just compare these two, so here in this reaction, alcohol is acting as a Bronsted acid and this is a Bronsted base because it is accepting a proton which is liberated by the alcohol, right? So this reaction also shows that the alcohol is acting as a acid, and which kind of acid it is? It is a Bronsted acid. So alcohol acts as a Bronsted acid. Right? Now student, here I am quoting this example. This is ROH, right? This is ROH. Here is another compound. So you can easily get it from here that I want to compare the acidic strength of the primary, secondary and tertiary alcohol. So student, among these three, which one is going to be more acidic in nature? Right? For this, let me tell you which will help out. This is there, having only one alkyl group in its surrounding. Now, what is the nature of student alkyl group? It is electron donating group, right? It is EDG, that is electron donating group. So, it will increase the electron density on the carbon atom, which will finally increase the electron density on the oxygen atom. As a result, student, the polar nature of O-H bond will get reduced, right? So the electron donating group reduces the polar nature of O-H bond, right? And hence what will happen? It will decrease the acidic strength. So if there are more number of alkyl group, here it was only 1, here student it is how much? It is 2 and here it is 3. So that means here the acidic strength, the polar nature of oxygen of O-H bond will be reduced to greater extent, here it will be less and here it is least. So among these three, the acidic nature of primary alcohol will be more, so this is going to be more acid, right? So if an electron donating group is present in the carbon chain, right, so it will reduce the polar nature of OH bond and hence the acidic character is going to decrease, right? This is about the alcohol, the acidic nature of alcohol. Now students, if we compare the acidic nature of alcohol and water, among the two, which one is going to be more acidic, right? So it is strange, but then also practically found also that water has got more acidic character than that in the alcohol. Now, why it will be so? Just having a look on the previous concept about the electron donating group. In alcohol, we have got an alkyl group which through plus I effect decreases the polar nature of O-H bond by increasing the electron density on oxygen atom, right? And whereas no such effect is found in water. This is the first reason that you can get, right? Now the second is that if we just write this reaction, students, ROH plus H2O, RO negative, sorry, RO negative plus H2O, right? This is alkoxide ion plus water. It has been found that the water has got greater tendency, right? So here it is this. So RO negative is acting as a base and water is acting as an acid. Right, the alkoxide ion should be there in the solution. We add alcohol to water, we will get alkoxide ion in water. Now the alkoxide ion will take a proton which is given by the water molecule and it will get converted to alcohol. We show that the water has greater tendency, water has greater tendency to liberate a proton. Right, that's why if we compare alcohol and water, students, which one is going to be more acidic? It is water which will act as more acidic. You can just do this reaction also, you can explain it, and you can also take the help of the inductive effect, which through plus I effect the electron density on the oxygen atom will increase, and as a result the polar nature of OH bond is going to decrease and the liberation of proton will become difficult. Right, now students, we will see the phenol. Now just I am drawing the structure of the phenol here. So we will first see that the OH bond in phenol, it is also, student, we will say that it is polar in nature due to the resonance, student. What will happen here due to the, we can say, minus I effect and the minus R effect? Here the electron cloud on the oxygen atom will come in conjugation with the benzene ring, right? And as a result, what will happen, student? It will finally try to get the electron cloud pulled from the hydrogen O dash H bond, right? So here it will get here negative in this way. This is it. So the lone pair or the electrons on the oxygen has come in conjugation with the benzene ring because of the minus R as well as minus I and minus R effect. So here we can draw the resonating structure further. So it will be in this way, right? So next, resonating structure. So you can see in the resonating structure that the phenol, there is the charge separation, right? So we are having the two charges together in the same structure. So it is making it unstable. So this is unstable. Now to gain the stability, what will happen, student? This one, we will draw the resonance hybrid of it. We are getting this double negative charge circulating here. This is positive here. This is H. Now to just get this charge separation, to get the stability, student, this positive charge, to get it removed, stabilized, this bond is going to break down, right? So the bond will get broken down and we will get the phenoxide. We will get a phenoxide ion here. This is H positive. A proton has been released, right? And the bond has again gone back. So we are getting in this way. So this is, student, of phenoxide ion which will be formed. And here you can see that there is no charge separation, so it's only having the negative sign. So if we compare the two, that is, this is more stable. So phenol will be always in the tendency to get stabilized by releasing a proton, right, and form the more stable phenoxide ion. So the acidic nature of phenol is because of the removal of proton, right, as a result of the minus I and minus I effect, so that it form more stable phenoxide ion, right? That's why phenol show the acidic nature. It also give a proton in the solution. Now students, we will try to draw the resonating structure of the phenoxide ion also. Right. So here also same, since the aromatic ring is there, so it will be, its lone pair will come in conjugation with it. Right, it will be here, this lone pair. So here you will see that there is no charge separation as was observed in the phenol molecule. So both the structures are there on the board, so it will help you to understand that what I mean to say here. Here you can see that in this phenoxide ion, there is only the negative ion is only there, right? In these structures we have only negative ion. But if you just see the phenol here, you can see that from this structure we are having plus and minus here, plus and minus here, plus and minus here. That means there is a charge separation, right? So if a charge separation is there, students, it will require more energy to get the species stabilized, right? So with respect to phenol, phenoxide ion is more stable, right? Therefore the phenol will have always greater tendency to show the acidic property. Now if we compare phenol and alcohol, student, since the phenol is resonance stabilized, right, and the alkoxide ion is not resonance stabilized, right, therefore comparing the phenol and alcohol, phenol is more acidic than alcohol, right. Again I am repeating, if we compare phenol and alcohol, students, the alcohol on liberating the proton will form alkoxide ion, which is not resonance stabilized, whereas in case of phenol, when a proton is liberated, it is liberated to form more stabilized phenoxide ion, which is resonance stabilized, right. So we have discussed now the acidic nature of alcohol, phenol, right, and we have compared the both, as well as we have compared the acidic nature of alcohol with water. Good morning, students. Today we are discussing the preparation of alcohols. So alcohols can be prepared from the haloalkanes, right? And it can be done by treating the haloalkane with aqueous KOH, right? So we will discuss the preparation. So first we begin with the haloalkane from haloalkanes. So here this is RX, which is a, can be alkyl halide, can be either chloroethane, bromoethane, plus aqueous KOH. The product form is alcohol and K will be released. Right? So the second is by from the alkene. Under the alkene, students, we have two methods. The first is acid hydration, acid catalyzed hydration of alkene. Right? So here we will take an alkene. Okay, so let it, we have got this across the double bond, right? So it's hydration, that means water in presence of an acid which is acting as a catalyst here. So student, here we will get, this is there, then alcohol is going to be formed. Now students, you have the mechanism of this reaction. So here the first step, students, will be protonation of alkene. Now protonation here will be carried in this way, right? For that student, protonation of alkene, it will be not directly from acid. For that, the first step which will be there will be water. It will get changed into the hydronium ion. It will form H3O positive. Now students, we are going to write here H3O positive. It is in this way. Right, so the double bond is here. You can show the shift either to this carbon atom or this carbon atom. If I show it here, so oxygen being more electronegative, it will just take up this hydrogen bond, break up the bond and take both the electron, and hydrogen, which is H plus now, will attack this carbon. So students, it will become this in this way. A carbocation is going to be formed. This I am showing here. This is the product which is going to be formed plus H2O. Now, second step is attack of water on carbocation. Right? So the second step will be attack of water on the carbocation. So oxygen lone pair. This is where here oxygen through its lone pair will get bonded to the carbocation. Right? Now the third step, student, will be the removal of the hydrogen atom. Right? So it will take place here. So next is removal of proton. So here this is OH, this is H, this is the lone pair and a positive charge of oxygen atom. So any one of the OH bond will break up, there will be removal of the hydrogen ion, a proton, and the OH group will get linked to the carbon atom. Right? So we will obtain alcohol from the alkene. Now student, here the alkene which is being taken, right, if we are considering it to be a symmetrical alkene, right, but if it is so that this is not a symmetrical but it's an unsymmetrical alkene, that means I am writing it here as CH3 CH double bond and this is CH2. In that case, student, the water will be, the hydroxyl group, this is CH3, this is CH, OH, and this is CH3. This will be the product which will be formed, right? And how this product is going to be formed, just have a look here. This is CH3. Now, just the steps will remain the same, student. We are just going to change the alkene, which is CH3, CH, this is double bond, this is CH2, right? So here if we are going to get, we will take two cases because here the two carbon are not symmetrical, they are unsymmetrical, right? So if this pi bond is being pulled by this carbon atom, if it goes this side, it will get positive here, it will get the negative, right, and H will get bonded to it. So in that case, we are going to get two carbocation, right? So let me, this is first case, the arrow mark, let it be A here I have written. So it is CH3, CH2, double bond is no more remaining, CH2, this is CH2 and I will get a carbocation here. This is when the arrowhead A is being followed. Now, when the arrowhead B, that means if the pi electrons are attracted to that CH2 carbon. That time, student, the carbocation which will be formed will be CH positive, and this is there. So this is the second. Now here, student, you can see that this is the primary carbocation which has been formed, right? And this is the secondary carbocation which is formed. Now you can easily predict here that which one is going to be more stable. So the second one, that is the B1 secondary carbocation, will be more stable. Now we will just select that one only. That means the attack of water on the secondary carbocation now. So it is CH3. This is CH positive. This is CH3 and the water molecule. Right. So it will now be written as CH3. This is CH and OH, which is in this way, oxygen getting a positive charge and a lone pair is there. Now one of the bond, right, let it be this one. Now we will do it in the next step. This is the product which is obtained when the water gets attacked, water attacks the carbocation. Now the next step, it is CH3, CH, this is OH, H and a lone pair and a positive sign, and here it is CH3. So one of the bond, O-H bond, will break up, and the product which will be obtained, it is CH3, CH, here it is OH, this is CH3 plus H positive. So this H positive, student, is getting removed. Right. So in this way we will show the product formation of the alcohol when the acid catalyzed hydration of unsymmetrical alkene will take place. Right. Now, student, the next is from alkene, which we can do is hydroboration of alkene, hydroboration oxidation of alkene. So here we are going to use diborane, right? So let's take this CH3, CH, double bond, CH2 plus, we will write down the boron in this form, H, BH2, right? So here the product which will get formed, we will get number of steps here, student. So the first step will be CH3, CH, this is H here, single bond, CH2, and this is BH2, right? So we have got alkyl borane, and now again we will have to take the alkene. So it is CH3, CH, double bond, CH2. Then again, now the boron has got two hydrogen atom here. So replacement will take place, substitution will take place around the hydrogen atom, around the boron, right? So it will be CH3, CH bond, CH2, right? This is getting now cold twice, and we will get here BH. Now again this reaction will take place. One more alkene molecule, and it will form CH3, CH2, CH2, hold, it was earlier twice, it will get now thrice, and this is B here. Student, we get here trialkyl borane. So this is the tripropyl borane which has been formed. Right. Now, finally, at last, we will get it hydrolyzed. We will get it hydrolyzed. with H2O2 in presence of an alkali can be an NaOH also, right? And the product form will be CH3, CH2OH plus, right? So we will get basically here the alcohol, the propyl alcohol which has been obtained here, student, right? This is the main product which we are going to get. So this hydroboration oxidation of alkene, student, it is taking place through the anti-Markovnikov rule. The acidic hydration, acid catalyzed hydration of alkane, student, it goes through the Markovnikov rule, and this, that is a hydroboration reaction, student, it goes through the anti-Markovnikov rule, right? So here the H plus and BH2, H plus is a positive and this BH2 negative, this is going to the carbon atom which is having more hydrogen atom. So this is in accordance to the anti-Markovnikov rule. Now student, next we are going to prepare the alcohol from the carbonyl compound reduction. Right? So let us take first aldehyde RCHO. If the reduction is catalytic reduction in presence of nickel, right? So it will get RCH2OH, right? Now similarly we can get it prepared done with the ketone, right? With ketone, students, we can either use the lithium aluminum hydride, or we can just carry out the first process only, that is reaction with the hydrogen in presence of nickel. That time this is RCOR dash. So in this case, students, we are going to get a ketone, sorry, alcohol which is secondary in nature, right? So here we get a primary alcohol, here students we are going to get a secondary alcohol. Now the carboxylic acid RCOH, students, to get it the best, either just reduction is there, right? We can perform the reduction here, right? But the best method is to get it converted into the ester at first. So for that we will get it reacted with an alcohol, right? So it will get converted into fruit smelling ester, and now this ester this ester can be treated with sodium dissolved in ethanol, or it can be treated with the lithium aluminum hydride, right? Or it can be treated even with sodium borohydride, right? To get the desired product. So it will be RCH2OH plus ROH, right? So we will get we will get a mixture of alcohol here. First one is the RCH2OH and second one is R-OH, right? So in this way we can get the alcohol prepared from the reduction of the carbonyl compounds, right? Now the next method is from Grignard reagent. Next we can obtain it from Grignard reagent, right? So we will take the first, let us take the aldehyde, formaldehyde, HCHO here, right? The Grignard reagent is RMgBr. Now student, here RMgBr, we have got C-Mg bond, right? RMg, we have got C-Mg bond is there. So C-Mg bond, student, it is polar in nature, Right, so here magnesium will get the positive and here this part is going to get the negative with respect to it. Clear? So that means this part is going to be positive and this part is going to be negative. So here when this reaction takes place, so we will get HC. This is the pi bond which will be shifted toward more electronegative oxygen atom. So we will get OMgBr. This is here R, this is H. That means we are getting here adduct, right? A product is being, we are getting this. Now in this product, it undergoes the hydrolysis, right? Perform the hydrolysis. That time, this bond will get broken down, and what we will get, student, we will get here HCOH and one more H is here, this is there. We can say the RCH2OH, right? Plus the other product which we will get is magnesium hydroxybromide. Water H2O, it is H plus and OH negative. So H plus will go to the OMgBr, oxygen atom, right? It will get ionized, and the OH part will go to the magnesium OHBr, right? So this is the preparation of the primary alcohol RCH2OH is student primary alcohol when we use formaldehyde. Now student, if we use aldehyde other than the formaldehyde, now let us take CH3CHO. We have taken CH3CHO, which is RMgBr. Student, I am writing here R. You can put any alkyl group here. It can be CH3 or C2H5. The product formed, the first step is OMgBr getting linked here. This is H and this is the R which will get linked to it. The second is the hydrolysis. So we will get here the product formed. Here in the first case the product was this. Now here it will be CH3, Cr, this is H, this is OH, right? Plus magnesium hydroxybromide. So you can see here that it is a secondary alcohol which is formed, right? So if we use any aldehyde other than the formaldehyde, student, we will get the secondary alcohol, right? Now if we are taking ketone, now student, if we take a ketone and get it reacted with the Grignard reagent. Now let us take here ketone is CH3 COCH3. Now here let me take this example CH3MgBr. Now what is going to be the product here? It will be first CH3 COMgBr. Here it is CH3, right? And this is CH3 which you are getting. Now hydrolysis. So you will get here CH3 COH CH3 plus MgOH that is magnesium hydroxybromide, and you can see here that this is the tertiary alcohol which is being formed, right? So when we use the formaldehyde, that time student we get the primary alcohol, and when we use secondary, that time the product formed is, sorry, when we use aldehyde other than the formaldehyde, a secondary alcohol will be formed, and when we use ketone, student, that time we can prepare a tertiary alcohol which is being formed, right? So the hydrolysis can be carried out by adding few drops of acid, so you can just get it mentioned here. Right? Now student, these are the main preparations of the alcohol from the carbonyl compounds, from the Grignard reagent, from the haloalkanes and from the alkenes. Just go through these and get it noted down.